Hello and welcome to today's lesson. It's lesson 6 in my GCSE preparation course series, and it's on quadratic equations. We covered basic quadratic equations last session, the factorising and solving, and we're moving on a little bit today, and we're going to focus on the quadratic formula and applied questions. Have a go first at the questions on this slide, just to wake your brain up a little bit and see what you've got from the previous sessions, because these are all based on the lessons I've already done. So while we're waiting for people to join, have a go at some of those questions. Welcome if you've just joined us. We're just doing some of these questions to start with, and then we're going to get going after a few minutes. Just a few reminders while you're working through those questions. You can download all the PowerPoints in advance from my website. The link is at the bottom of this page and also the last slide on here. And then you can have a go at some of these questions beforehand if you want. So if you find it easier to work in your own time and want a bit more time to do the starter questions and some of the other ones, then it's worth downloading them in advance and just having a go at that starter. If at any point you're stuck on a question and want me to explain it, then please just type in the comments box or the chat box, and I'll try and get back to you. I'll go through it as soon as possible. So just message in the chat box if you've got any question at any point. Welcome to those who've just logged in. We're just doing 1 more minute on these practice questions, questions 1 to 4. 1 minute. Right, I think we're going to go through some answers. Again, remember you can download them in advance if you want a bit more time to go through any of these questions. Okay, so I'm not going to go through exactly how we do these because these are all based on previous lessons I have taught. So you can go back and watch the old videos if you need a little bit of a reminder, because today we are going to focus, as I said, on the quadratic formula and applied questions. But I will put the answers up so you can check where you got the marks correct or where you made little mistakes. So factorising the first one is our basic factorising, and we get x plus 4 and x plus 6. You could have those brackets either way around. With our second one, it's a slightly more challenging quadratic, and this time we get x equals minus 1 and x equals 3 over 4. This one said solve, not factorise, so you had to factorise and then flip the signs. Question 2a, we had to circle the value of 3 to the power of minus 2. We get 1 over 9. And for b, it was 1.25 or equivalent. So OE just means or equivalent. So you could have written 1¼ or 5/4 or anything that means the same as 1¼ For question 3, we should have got the ratio 1 to 2 to 5. It has to be right down in that simplest form to get the mark there. And question 4, we should have got down to 28 minus 10√3. Just a little hint with that one, write it as double brackets first. 5 minus √3 times by 5 minus √3. Then expand and simplify. Okay, so if you struggled on any of them, these are the lessons that they are in. So question 1 was based on lesson 5, that was Mondays this week. Question 2 was based on lesson 1 on indices. Question 3 and 4 were on lesson 2 on surds. So do go back and have a little look and see if that helps. All right, let's get on with today's content then. So today we are going to look at using the quadratic formula. So I'm going to be giving you some little tips and hints for kind of putting it into your calculator and how to stop getting negative errors if some of you are often getting some errors there. We're then going to be moving on to applied quadratics. So these are those sort of shape problems and nasty worded problems where they sneak quadratics in. So you don't know there's a quadratic until it suddenly appears. My favourite kind of question. And then in the future at some point we'll be doing all the rest with quadratics. So we've got completing the square to come, we've got graphs of quadratics, and we've got further applied quadratics. So quadratic inequalities, quadratic sequences, quadratic simultaneous equations, and so on. So there's a lot to do with quadratics. They pop up in so many different areas of maths. But today we're just going to be focusing on the formula and then shape and word problems. All right. Here is the quadratic formula. Should be familiar to you, as this is just a recap towards kind of the end of your year 10. But you've had a few weeks away from it maybe, you've been doing other topics. You've got to remember this, you've got to learn it off by heart. So that bottom bit of the box there, the x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. That must be in your memory and able to recite it in a flash. We actually use this formula when we can't factorise a quadratic expression or equation. So this is to find solutions when it does not factorise into two brackets. It's most commonly used on a calculator paper, but you may need to use it on a non-calculator paper, and you just leave your answer as a surd if it's not a nice square number. So it's sort of on both there. You can just type it into your calculator for calculator paper, but you do need to know how it works as well. The top bit is just telling you what format it must be in order to use the formula. So that means we must have a number of x squareds, b, a number of x's, and c, a constant. And it must equal 0. So sometimes you have to do a little bit of rearranging first in order to get it looking like that, equaling 0, and then you can plug it into the formula. You'd have to rearrange it anyway if you're going to factorise and solve it. So that's always the first step. Once you can spot a quadratic, rearrange to make it equal 0. The bit under the square root, the b squared minus 4ac, is called the discriminant. Now this is a bit you may or may not have touched on, depending on your school, your class, and what they're doing with you. But this has been brought down from A level, so it's a bit of further maths there. And it tells you a bit about the properties of that quadratic, because it tells you how many solutions there are. I'm going to focus on this more when we do graphs of quadratics, because you can really see the solutions on a graph where it intercepts the x-axis. But here it does tell us how many solutions there are, so it's a bit interesting. The b squared minus 4ac, so the discriminant, if that's less than 0, it means there are no real solutions. If you think about that, if it's less than 0, that means it must be negative. And that's the bit under the square root. So if you're trying to square root a negative, we can't do that. So therefore you would get like an error on your calculator or no solutions. If the bit under the square root equals 0, then that means there's just one solution. Because when you do the plus minus in the middle of the formula, if you plus or minus 0, you're going to get the same answer. So that would be a case when there's just one solution. And if the b squared minus 4ac is greater than 0, so basically any positive number, then there are two solutions. And that's going to be most of the examples you'll find. You end up having two solutions for your x value. All right, again, don't worry too much about that bit. We will touch on that in graphs, but it's they like throwing in those kind of questions and asking you how many solutions you'd expect to find, and you don't have to work out the whole question if you can just spot the b squared minus 4ac, the discriminant, and use that. Okay, let's get going with an example then. I'm going to talk about best practice and how to do this. So if you are confident using the formula and you're happy typing into your calculator, you're getting the correct answer all of the time, then carry on doing it how you do it. But if, for example, you're getting some errors come up on your calculator, or you're always slightly out, or you're getting different answers, then it will be your calculator technique and how you're putting it in. So listen really carefully and follow what I'm doing for a kind of foolproof way of not making a mistake. So we're going to look at this first question here. So solve 3x squared plus 10x minus 6 equals 0. It's already in the right format. We've got our x squareds, x's, the number, and then equals 0. So that's great. We don't have to rearrange. So we're just going to plug it into the formula. Now the best thing to do is separate out your a, b, and c values. So here a equals 3, because that's the number in front of my x squared. B equals 10, because that's the number in front of my x's. And C equals minus 6. So be careful there, we've got to get the sign in as well. So if it's a negative, it's got to go there. So separating them out really helps you not kind of having to look back at the formula all the time, making sure you've got them right. So if this was a question and you didn't have the formula just to the left of you there, then I would rewrite the formula first before you do anything else. But because I've got it just on the left, I'm just going to start substituting in. So we've got minus b, so I'm going to write minus 10 plus minus square root of b squared, 10 squared, minus 4 and then ac times a, which is 3, times, now c is a negative. Now I would always recommend putting negatives in brackets. Now that's because some calculators are a bit funny with negatives and you have to use a slightly different button for them. You have to use a separate one for the negative or just a subtract. But this way stops that being an issue. It knows that that is a negative and it won't make any kind of negative errors. So again, if you're fine with the method you're doing, that's fine. But if you're having issues, then this will help. Then this is all over 2a. So that is 2 times 3. And you'll see I've left even simple bits like the 2 times 3, I've written them out. If they're simple and you can definitely do it in your head, just write it down as 6, for example. But if you're making issues, again, it might be your mental maths. So if you're about to type this into a calculator, just write out the pure numbers just like that. Always write this step, even if you're super confident, always write down the substitution, because if, for example, something goes wrong in your calculator, and it's so easy for one little button to go wrong, then you will still get a method mark for substituting into the formula. So always do this bit. Now I'm just going to type that in and see what we get. You might want to practice your calculator technique and see what you get there. But we should get one answer. So firstly, I've put the positive in, so minus 10 plus the square root. And we get, now remember this is to 2 decimal places, so we get 0.52. And then I'm going to type it in with my negative instead, and I'm going to get minus 3.85. Okay, so those are my two answers. If you've got a graphical calculator, which some of them are allowed now at GCSE, it does actually have a quadratic formula kind of solver for you, so you can just type in the question and you get the answer. Now, if it was just a plain question like this, that is absolutely fine, but it won't always be a plain question like this. They will sometimes have it on a non-calculator paper, so you can't just type it in. They will sometimes have sort of part of the step, so you need to pick it up halfway through. So again, you won't be able to type it in. There might be a spot the mistake type question. So basically, you can just type it in if it's a straightforward answer like this, but you need to know the formula, you need to know the method and how to do it yourself, just depending on the question. All right, hopefully we're okay with that one. Let's give you one to try. And try typing it into your calculator and let's see if you get the right answer. All right, give you 1 minute. All right, should we have a look at this one together? So we should have A equals 8, B equals minus 10, C equals minus 5. When we substitute it in, now remember we've got negatives here, we want minus B. B's already negative, so it's going to be positive. Plus minus square root of minus 10 squared. Now, that's actually going to be exactly the same as 10 squared, so it doesn't really matter about the negative on this bit. But again, if you're wanting your technique to be flawless, just pop it in a bracket, minus 10 squared. And then minus 4 times A times C. All right, all over 2 lots of A, so 2 lots of 8. And then you can pop it into your calculator. So when we're doing this, we should get, now this one, careful, it's to 2 significant figures. Try to catch you out slightly there, not decimal places. So that means our first answer is 1.6 and our second answer is negative 0.38. Okay, so we've got 2 answers there, both to 2 significant figures rather than decimal places. All right, hope you got on okay with that. Go back, if you made any mistakes, check that method, check it with what I've typed in there and check your negatives. That's the most common error. Okay, we're not going to do any more formal practice on the quadratic formula because I think once you've got it and you've got your technique, you're fine. We're going to go straight onto those applied questions and spotting quadratic equations. So I just want to give you a hint for when to spot we need to use the formula. So there are kind of 3 main ways that the question will tell you without using the word use the quadratic formula. The first one is if the answer is not a whole number. So if they're saying give your answer to 2 decimal places or 2 significant figures, that should give you a little bit of a hint that it's going to need the formula, not just factorising into brackets. Secondly, it may ask you to leave it as a surd or as an exact value, which basically means a surd. And in that case, it's sort of probably going to be on a non-calculated paper and you'd use the formula, but it would be nice enough numbers that you can simplify and leave it as the surd form. Or thirdly, if the equation does not factorise easily. So if you're doing the question, you're spotting it's not factorising, then go straight to the formula. But sometimes it might be that it does factorise, you just can't spot it. It's really big numbers and it's taking you way too long, and it might actually be quicker just to plug it into the quadratic formula. So have a look at these questions here. I'm not going to ask you to do these, but just look at them and see if you can work out why they're asking you to use the formula. So can you see the little hint there that's telling you to use the formula? Okay, so in the first one it's saying to 3 significant figures, that's your hint. That's the same with the third one there, 2 decimal places. In the second one it's saying leave it in the form of that, looks quite like the formula. And in the last one it says leave it as an exact value, so that's a hint that there might be a surd in there. With the fourth one, it's just quite a tricky number, the 288, and you might spend ages trying to work out what multiplies to give minus 288, but adds to minus 2. Now, you can try these as extra practice if you want after the session. I'm just going to get rid of that so you can see them better. So you can pause it if you're watching this again and have a go at those questions to see if you need more practice with the formula. So I will put up the answers now so you can mark if you've done that. Okay, those would be the answers for those questions. Okay, let's try some applied questions then. So this is just some of the areas that we can apply quadratics in. And as I touched upon at the beginning, we're going to focus on shapes. We're going to look at some area problems. We're going to look at some worded problems. And we're also going to look at some problems with Pythagoras. So that's kind of the three main bits we're going to be looking at today. Right, let's have a look at some area problems. So we've got a nice simple area problem here to start with, which I'm going to go through with you. I've cut off the question, but it would say something like, find x. So here we know that length times width is the area of a rectangle. So 2x times 3x should give you 150. Simplify that down. 6x squared gives you 150. Divide by 6 on both sides. Okay, nice way to divide by 6, divide by 3, then divide by 2. A bit easier. Now we've got a simple quadratic, x squared equals 25, x equals plus or minus 5. No factorising needed if it's this simple. Now that's just a reminder that you could have a negative answer there. When you square root something, you've always got those two answers. In this case, it's not going to be the minus because we're talking about length of a shape. So my final answer would be x equals 5 centimetres. All right. Nice simple one there, didn't need to factorise or anything, but they do get a little bit trickier. So one for you to try. Have a go at this one. Just a little hint, use double brackets. Right, should we go through this one? Don't worry if you haven't quite finished. I'm going to go through the starting bit, which hopefully we've all got. So we should have x plus 3 multiplied by x plus 5, and that gives us 26. So then we need to expand those brackets and simplify, and we'd get x squared plus 8x plus 15 equals 26. Now it's looking a bit more like a quadratic, so you see how it's popped out there. Now have a look what's different to that to the format we need it in our formula. Can we spot that it doesn't equal 0? So we've got to subtract 26 from both sides. So we get x squared plus 8x minus 11 equals 0. Now it's in the format that we can either factorise and solve or use the formula. Now have a think, does it factorise? Two numbers which multiply to give 11, that's only going to be 1 and 11. Can they somehow make 8 when you add them together? Nope. So it doesn't factorise, we're going to need the formula. Again, I don't have it on this page, so I'm going to write it out. And I would always do this, so I'm not making a mistake. b squared minus 4ac over 2a. The more you do this as well, the more it sticks in your brain. So then I have got minus b, so minus 8 plus or minus square root of b squared, so that's my 8 squared, 64, minus 4 times, now a is just 1 here in front of the x, so I'm not going to bother writing it in, because if you times it by 1 it just stays the same. So I'm going to times it by minus 11, that was the c at the end. All over 2a, so 2 lots of 1, which is just 2. And when you type that in, you will get the answers of 1.5 let's go to one decimal place here. It hasn't asked, but we'll go for 1.2, or we'll get minus 9.2 if we use the negative version. Okay, so that's how we factorised our quadratic, or not factorised, but found the solution using the formula. Look back at the question. Because it's a length, it can't be your negative answer. It means when you substitute it in, it can't be negative. So just double check, minus 9.2, if I add 3 to it, looking at the height of the shape, it's still negative. So that means it can't be our answer. So x must be 1.2. Now if it said find x, that's your answer. We get 1.2 centimetres, lovely. If it said find the height, you'd have to substitute it back in. So be careful and read the question carefully if I've given you one. All right, let's try a slightly trickier question. So the key here is to setting up the equation, then it's even easier, I think. So I'm just going to give you maybe 20 seconds to see if you can set up the equation. So that's the first bit I'm interested in. Off you go. Right, let's go through this question together. So we've got the area of the rectangle, so that's going to be this value multiplied by this value. Write the second one in brackets because it's got 2 terms, is equal, so we can just write our equal sign, to the area of the square. So x times x is x squared. Okay, so that's our starting equation. Hopefully we're all happy with getting that. Now we can expand and start to simplify. So we get 2x squared minus 4x equals x squared. And now it's starting to look like a quadratic, but we've got x squared, we've got x's, but we've got x squareds over here as well. So let's subtract that so it starts to equal 0. If I take away x squared from both sides, I'm just left with 1x squared on this side, and it now equals 0. Now this is actually a simpler quadratic to solve because we don't have the plus c, we don't have that extra number. So I can just factorise by dividing by x. So take x outside of your brackets and we're left with this. Okay, which looks like it is in factorised form. The bracket we can solve just as normal. Flip the sign, so that means one of our answers is x equals 4. And this x, whenever you've got an x on its own, or that could be like a 2x, a 3x, but basically one term outside of your brackets, that means one solution is going to be 0. And that's because this something outside the brackets, the x, times the brackets equals 0. So either the x is 0 or the x minus 4 is 0. So that's how we get our 2 solutions. Now x could not actually be 0, otherwise that square would not exist. It would just be 0 times 0. So we know that our solution is x equals 4. Okay, hopefully we're happy with that. Let's move on now and look at some worded questions. So they've got no shapes here, just worded questions. And the tricky bit here is setting them up. I'm going to do the first one with you, and then you're going to have a chance to try the second one. So let's have a look at this one together. 2 positive numbers which differ by 3 have a product of 88. Find them. So 2 positive numbers. Now it doesn't say that they're even, they're odd, or they're consecutive. It's just 2 positive numbers which differ by 3. So let's choose x for one of them. So if you have any unknowns, we can use algebra to find them. Now if they differ by 3, that means our next number we could write as x plus 3. We could have written that as x minus 3, it could have been 3 less, but then you're giving yourself a negative to work with, and it just makes it more challenging. So you might as well make it a positive, x and x plus 3. Now we've got our 2 positive numbers which differ by 3. They have a product of 88. So that means when you multiply them together, so here we're going to do that by using brackets, we get 88. Now it's similar to the previous question. Let's expand it. X squared plus 3x equals 88. Now we need it to equal 0, so subtract 88. X squared plus 3x minus 88 equals 0. So two numbers that multiply to give minus 88 and add to make 3. That is going to be minus 8 and plus 11. So our solution there is x equals 8 or minus 11. Now if we look back at the question, they're two positive numbers. So x can't be minus 11, so I know it must be 8, but I also want my second number. Now we found x, one of our numbers was x, we chose to write the other number as x plus 3. So that means our second number, our x plus 3, will be 8 plus 3, which gives us a positive 11. So our answers are 8 and 11. Okay? It just happens in this scenario that that was a negative 11 and our answer is positive 11, but you can't just change the sign. It's not always going to be the case there. You have to look back at your original question. Okay, do you want to have a go at one? This is a tricky one to set up, so I'm going to give you a little while to try yourself, and then I'm going to silently write the first step on the screen. So if you need a hint, have a look at the screen in a minute. Okay, I'm just going to go through that starting bit. It's tricky to find those, and this is helpful in proof questions as well. If we want odd numbers, we have to write 2n plus 1. That's because if I just chose to use the letter n, that represents any number. So it could be positive, or it could be even, it could be odd. To make it even, we'd times it by 2. So 2n is definitely going to be an even number, because whatever it is to start with, if you multiply it by 2, we get an even number. So therefore 2n plus 1 will always be odd. So that's the only way I can guarantee it's going to be an odd number. Now we want them to be consecutive, so I want the next odd number. So I've got 2n plus 3. If I had 2n plus 2, that would just give me another even number. But I want to skip the even number and go straight to the next odd number. So that's how we start that up. Okay? I'm going to do the rest with you because the tricky bit there was setting up that equation. So the product of these numbers is 143. So that means we're going to multiply them both together and we should get 143. So let's start our expansion. 2n times 2n is 4n squared. Then we're going to have plus 6n, so I'm doing it this way here. Then we're going to have plus 2n and then plus 3 equals 143. Let's tidy that up a bit. Okay, now it's starting to look like our quadratic. It's got to equal 0, so we've got to subtract 143. So 4n squared plus 8n minus 140 equals 0. Now it gets to this stage and it looks a little bit nasty. If you're going to do your normal technique, you'd have to do 4 lots of 140, then try and find your numbers. Okay, nasty. If it's a calculator paper, you could just type it straight into your calculator and get the quadratic solution, fine. But if it's a non-calculator paper, you can always simplify. Once it gets to this stage, we can actually just divide by 4. Because if you divide 0 by 4, it just stays as 0. So we're not actually changing the equation, we're just simplifying it. So 4n squared divided by 4 is n squared, plus 2n now, because we've divided by 4. 140 divided by 4, a little trick for dividing by 4 is to halve it and halve it again. So we get 70, then we get 35. So suddenly, without doing any hard work, we've got a really nice basic quadratic, which we can now factorise and solve. The solution there, or the factorised version, would be n minus 5 and n plus 7 equaling 0. And then when we solve this, we flip the signs and we get n equals 5 or minus 7. Now look back at your question at this stage to check, have we answered it or do we need to do anything else? So I know that it's going to have to be the positive version because we've got positive numbers there, can't be that minus 7. But that's not my odd number, because I want two positive consecutive odd numbers, that'd be 5 and 7, but when I multiply them together I don't get 143. That's because my numbers were actually 2n plus 1 and 2n plus 3. So now that I've found n, I've got to substitute it back in to find my number. So we do 2 lots of 5 plus 1, which gives me 11, and 2 lots of 5 plus 3, which gives me 13. Those are my numbers. Okay, so always remember to substitute it back in to your original terms that you came up with for the numbers. You can always check it in the question as well. If you multiply 11 and 13 together, you do get 143, and they are positive consecutive odd numbers. All right, good, well done with that. Let's try 2 more word problems. With some of them, the key is to draw a diagram. So have a little read of this and think what we're going to do. So the height of a photo exceeds the width by 7 centimetres. So therefore, if my width was x, my height would be x plus 7. Okay, it doesn't say it's 7 times bigger, it just said it exceeds it by 7. So it's just another 7 centimetres. If the area is 60, find the height. So this again is one of our nice ones where we multiply them together, area question but just in words, and I get 60. Just going to do this one quickly because it's the same as the other processes we've been doing. Expand, move your 60 over to make it equal 0. And then we've got to find our 2 numbers which multiply to make 60 and add to make 7. In this case, we have actually got, what have we got? 12 and minus 5 for this one. I always find this one tricky to spot for some reason. X plus 12 and x minus 5 equals 0. So right in there. So x could either equal minus 12 or positive 5. It's going to be positive 5 because it's a length. Okay, so the same process there, the tricky bit there was just setting it up from the worded question. Okay, I'd like you to have a go at this one now, please. It's not quite as tricky as it looks, but read it a few times if it seems a bit confusing to start with. Off you go. Oh, sorry, I am just going to mention on the last one, having a look back at the question, 5 is not our final answer. Well done if you spotted it. Can you see what we need to do now? Yeah, it wants the height. Okay, that's just caught me out there. We found the width, haven't we, which is our x. The height was x plus 7. So our height, x plus 7, 5 plus 7 is actually 12 centimetres. Okay, always read back at the question and just check you've done the answer. Right, you carry on with the second one now. Okay, should we start to go through this one together? So we've got 3 consecutive positive numbers are written as x, x plus 1 and x plus 2. It didn't need to give you this bit. You might have to know that you can write consecutive positive numbers as x, x plus 1, x plus 2. Okay. The square of the largest number, so that's going to be our x plus 2, is 45 less than the sum of the squares of the other numbers. Right, there's a lot going on there. Let's start with the first bit, the square of the largest number. So that's going to be x plus 2 squared. Okay, the square of the largest number. It's 45 less than the sum of the squares of the other numbers. So let's square the other numbers. And I've added them together there because we want the sum of their squares. Now it's not equal, it's 45 less. So that means we would add them together and then take away 45 in order to make them equal. Alright, so just read through that again. The square of the largest number, which is x plus 2 squared, is 45 less than the sum of the squares of the other numbers. So you add together the squares of the other numbers, you take away 45, that should be the same as your largest number squared. So that's the tricky setup. Now you've got to do the expanding and factorise and simplifying. Whenever you're doing x plus 2 squared, think of it as 2 brackets. Okay, we've got x plus 2, x plus 2, because it's not just x squared plus 4. We've actually got x squared plus 4x, because we've got a 2x and a 2x, and then we've got our plus 4. So just be careful, whenever you're doing double brackets, imagine it as 2 brackets next to each other, if it's a squared. Then we've got our x squared from before, then remember this one is x plus 1, lots of x plus 1. So we get an x squared, then we're going to get 2x when I have 2 lots of 1x, and a 1, and then minus 45 at the end. Okay, so it's nice long, we've got a lot of x squareds in there, so we need to try and collect them together. I've got 2 x squareds on the right hand side and only 1 on the left. So I'm actually going to make my left hand side 0 and collect everything on the right. That's just to avoid the x squared being negative. Okay, so let's just cancel those ones out. We'll take away x squared from both sides. If I take away 4x, I'm left with x squared there. Now moving on to your x's, I've got 2x on the right hand side. I'm going to take away 4x, so that means I'm left with minus 2x. And then I'm going to take away 4, but I've got plus 1 minus 45. So I've currently got over here minus 44. If I take away another 4, I've got minus 48. Okay, I did a few goes in one there, but you could simplify it in different stages, but that should be what you end up with. Doesn't matter if it's on the left or the right, but we should have a positive x squared there. If you've got a negative x squared, just change all the signs. It's basically the same as you moving them to the other side of the equation. Now we can factorise, and we end up with x minus 8 and x plus 6 equaling 0. So we get x equals 8 or minus 6. We know they were positive from the question, and so there were 3 consecutive positive numbers, so that means it must be 8. So that was my original x. Remember my numbers were x, x plus 1 and x plus 2. So that means my answers are 8 and then 8 plus 1 and 8 plus 2. Final answers. Alright, and always just check it works if you want to. So we can square the largest number, we get 100. Is that 45 less than 8 squared plus 9 squared? So 81 plus 64 gives us 145. So 100 is 45 less. Okay, always worth checking with those ones. Right, final lot of questions that I'm going to do with you today, and then I'm going to leave you some to practice in your own time. Okay, so we just got 2 more questions left here. This one I've put in because I'm not telling you what the topic is. I want you to see if you can spot it. I will tell you, however, that this is a right-angled triangle. All right, see if you can spot what we need to do here before I go through it. Have a moment. Right, have we spotted it's Pythagoras? Yep, right-angled triangles, and we're talking about lengths. It's not trigonometry. There could be trigonometry here. We could have angles involved, but it's just lengths, so we're just going to use Pythagoras. Okay, so our Pythagoras formula is a squared plus b squared equals c squared, where c is the longest side, so that's our x plus 8. So let's just substitute in our values. So I'm going to call that one a and that one b. It doesn't matter with the shorter sides, you can switch them around. So let's have x plus 6 squared plus x minus 1 squared, and that should be equal to x plus 8 squared, so our longest side. Now I've got 3 lots of double brackets. Remember, picture that first one as x plus 6 times x plus 6, expand it and so on. I'm going to go through what we get down here. So when I expand it all, I would get x squared plus 12x plus 36 for my first bracket. For my second one, we'd have x squared minus 2x plus 1. And that would be equal to x squared plus 16x plus 64. So we've almost got 3 quadratics in one there. We still need to simplify them. Look at what side's got the most x squareds on. So we're going to keep them on the left side here. So let's get rid of this x squared, which will cancel with one of them. So I'm just left with x squared. I want to take away 16x. So I've got 12x minus 2x. So I've got 10x on my left-hand side. Take away 16x, I'm left with minus 6x. Then I need to take away my 64. So I've got 36 plus 1, I've got 37 there. If I take away 64, I'm actually down to minus 27. And I'm left with 0 on the right-hand side. So we've suddenly got a nice quadratic again. This one factorises to minus 9 and plus 3. So that means our solution is either 9 or minus 3. Substitute some of them in just to check whether it could be that minus 3. Minus 3 plus 8 would give us a positive, so that could work. Minus 3 plus 6 would give us a positive, so that could work. But minus 3 minus 1 would give us minus 4. So therefore we know it's got to be the positive 9. Okay, so it's just showing how it's not always not the negative. It's just here with it doesn't work with the very last bottom side there. Okay, well done if you got that one and spotted it was Pythagoras. Final question then is on a trapezium. Can you remember the formula for the area of a trapezium? See if you can, and in a little moment I'll write it down for those who need a little hint. Okay, so the formula is a plus b divided by 2 times by the height. And that's where a and b are the parallel sides, so that's our x and our 20, and h is your perpendicular height. So it's got to be the right angles, not the slanty line. It's got to be that straight up height. So let's sub that in, and it's a show that question. I really like these questions because you know you've got it right. Okay, as long as you get back to that, you've got it right. So a plus b, we end up with x plus 20 over 2, and then times by the height, which is 2x. And that should be equal to 400 because they've told us that's the area. Now, if you multiply by 2x, it's just the same as multiplying the top of the equation by 2x. So we would end up with 2x squared plus 40x over 2 equals 400. I've run out of space a bit, but can you see that fraction? And we divide it by 2, we just get left with x squared plus 20x equals 400, which is what they asked us in the show that. Okay, so it's nice and simple as long as you've remembered your formula. Then it says find the value of x, give your answer correct to 3 decimal places. What is this a hint of? 3 decimal places. Formula. Okay, we've got to use the formula. We've got to do something first to our equation. Can you tell what we've got to do? Yeah, subtract the 400 to make it into the right format. Minus 400 equals 0. Then plug it in to your quadratic formula. It wants it to 3 decimal places. I end up with 12.361 or... Sorry, my program just crashed on that. I'd written the final answer anyway. I'm not going to rewrite that all again. So for the trapezium question, part B, we got 12.361. We also got the negative answer, 32.361, but it wouldn't be a negative because x is a length there. So the final answer was 12.361. Hope that's okay. Right, that was it for the questions you're doing today. I've got some extension questions here. So that when you're watching this in your own time, you can pause it and have a go if you need any more practice at those questions. So that will be on this slide and the answers are coming up now. Okay, and you could pause it to go through them when you need to. I've also got some additional practice questions. So the previous ones were extensions, so slightly more challenging. These ones are sort of more of the same if you just need a bit of practice with some of those complex shape questions. Okay, pause it if you want to have a go at it. And again, answers coming up now. Okay, and you can pause to mark once you've done those. But that's all there for you when you want to practice. Oops, sorry, I didn't mean to zoom in there. Right, that is the end of today. Well done, because it's quite a lengthy one with all those applied questions. All the PowerPoint and the annotations can be downloaded from my website. And there are extra practice questions on sort of the basic quadratic skills on Corbett Maths. 118 to 120, 266 and 267. If you're struggling and you want some more questions, if you search for quadratic shape question or quadratic shape problem, you should get some of those up. But if you've got any problems or any questions, then just message on either the chat box now or the comments box if you're watching this after the session, and I'll get back to you as soon as I can. Next week, we will return at 5 p.m. on Monday the 8th on both YouTube and Facebook. And we'll be continuing with quadratics, but we'll be moving on to completing the square, which is, I know, a nightmare topic for a few of you, and quadratic graphs. I love quadratic graphs because it brings it all together. So it's kind of recapping a lot of these topics we've talked about, but putting it all into the graph scenario. Okay, make sure you subscribe on YouTube, give me a like if you can, and follow my Facebook page for updates. For example, like yesterday's session, I had to postpone until today, and I put that on the Facebook page. All right. Well done today. I'll see you on Monday.